The way that we typically do delta epsilon problems when first introducing calculus is to start by converting the inequality on the right here to two inequalities, negative epsilon less than square root of 16 minus 2x minus 2 is less than epsilon, and then gradually convert this to inequalities involving only x. So next step would be to add 2 to both sides. The next step is to square. Now technically, we can only the inequality will only be preserved if everything here is positive. However, epsilon is usually going to be a positive number, so if epsilon is less than 2, small positive number, so if epsilon is less than 2, then the left-hand side here is still positive, so I can square everything and the inequality is still preserved. But that's a technical point that we can't just simply square this without the assumption that epsilon is less than 2. If epsilon is bigger than 2, of course, then we can make choose an epsilon that's smaller than 2. And if it's less than that epsilon, then it's going to be less than the original epsilon. So it's okay. But we have the assumption here that, just going to make a note on the side, that if that epsilon has to be smaller than 2 to make the next step work. So squaring everything, I get 4 epsilon squared. 4 epsilon plus epsilon squared is less than 16 minus 2x, which is less than 4 plus 4 epsilon plus epsilon squared. Okay, so minus 16 and everything, we get minus 12 minus 4 epsilon plus epsilon squared is less than negative 2x is less than negative 12 plus 4 epsilon plus epsilon squared. And finally, dividing by negative 2, the inequalities change directions, so I get 12 plus 4 epsilon minus epsilon squared is greater than 2x, which is greater than 12 minus 4 epsilon minus epsilon squared. Okay, then finally divide by 2. I forgot to divide by 2, so I get 6 plus 2 epsilon minus epsilon squared over 2 is greater than x, which is greater than 6 minus 2 epsilon minus epsilon squared over 2. Okay, so as long as epsilon is sufficiently small, if epsilon is less than 2 for instance, then the inequality at the bottom is going to be some interval that is centered, that includes 6. So I have 6 plus something, then 6 minus something. So this is going to be bigger than 6. This number is less than 6. So just to draw the picture here, so here, I have a number line here. 6 is right here. On this side is going to be 6 plus 2 epsilon minus epsilon squared over 2. On the other side is 6 minus 2 epsilon minus epsilon squared over 2. And so delta can be chosen to be whatever the smaller of these two numbers is. Whatever the smaller of those two distances is, that'll be the choice for delta. So delta will be equal to the smaller of, well, this distance here is clearly 2 epsilon minus epsilon squared over 2. And the distance between here, if I take 6 minus this thing, I would get 2 epsilon plus epsilon squared over 2. And here it's pretty clear which one is smallest. It'll be 2 epsilon minus epsilon squared over 2. So that's going to be the delta. Now to actually finish the proof, we have to run backwards. We kind of worked backwards here, starting with what we're supposed to end with and end with the start. So now that we have our guess for delta, we need to start with this and then start with this absolute value of 6 minus x minus 6 is less than 2 epsilon minus epsilon squared over 2, and then slowly convert that to an inequality with that looks like this, and double check that indeed it's going to be less than epsilon. So that's the logic for problem number 2. And that's typically how we present delta epsilon arguments, if we present delta epsilon arguments to calculus students.